Hello everyone, welcome back to my channel. So today's paper will be based on Cambridge International ASN A level chemistry paper 970122 May June 2021 series. So let's get started. So first question, a group of two metal combines with bromine to form a crystalline solid which is MbR2. Excess aqueous silver nitrate is added to a solution of MbR2 and a precipitate forms. The mixture is filtered, the, fil- the precipitate is dried, and the mass of the precipitate is recorded. So, first we know that it's going to be a crystalline solid of bromine along with one mixture, okay, and mixture which is going to be of group 2 metal. Now, whenever we are going to use the bromine, obviously we're going to get a cream PPT, as you all know, when it having an excess of AgNO3 added. So, state the formula and color if they're asking you. So, formula will be silver bromide, okay, and it's going to be displaced one, and the color will be cream. So, 1 mark for formula and 1 mark for color. Complete the equation to represent the reaction between MbR2 and AgNO3. So over here they have already given us a metal bromide and AgNO3, which gives us Ag bromide, which is silver bromide, along with the nitrate. So over here, once we're done with the completing the equation, we have to balance the equation. 1 and 2 is the answer for respective equation. Question number 3. A sample which is of 0.250 gram of pure MbR2 is given to us, contains these many moles of MbR2. Calculate the relative formula mass Mr of MbR2. Use this to identify M. Show your working. So first we're going to calculate Mr of MbR2. So Mr relative mass we do not know, that we need to find out. So we take mass upon moles. So mass is given to us and mole is also given to us, which we can get Mr of MbR2. Then we can find the AR of Br, which is 79.9 from the periodic table you will get. But we must know that it's going to be Br2. Okay, 2 atoms of bromine. So we're going to multiply with 2. So 79.9 times 2, which gives me around 159.8. We know the Mr of MbR2. We know the AR of Br. So we can reduce this to get M value, which is 297.08 minus 159.8, which gives me 137.28. So Mr will be 297.08, which we have already got. Also, M value for 297, if we see from the periodic table, it's going to be barium. Okay, so total 3 mark of question. Now, next one. A sample of MbR2 is dissolved in water. Chlorine gas is then bubbled into the solution. Describe the observation for this reaction. So once we get a displacement reaction, we can see here that Br and chlorine. So whomsoever is going to be more reactive, that will get displaced. So if I see about who's going to displacing what, so chlorine is more reactive than bromine. So we're gonna get as red, brown, or orange color also you can mention, which has been observed. And you can also say in the reverse order where yellow green color fades because of the chlorine. Okay, so next question. Name the type of reaction that occurs when MbR2 reacts with chlorine gas. As I mentioned, it's going to be a displacement reaction. Question E. Compound Y is a pure insoluble solid which contains halide ions. A single reagent is added. Now we have to more focus on a single reagent is added directly to a compound Y to determine the halide ion present. So for the halide ion, we always use silver nitrate, right, and nitric acid as well. But over here, we have been focused on single reagent. So reagent which we use for it is concentrated H2SO4, which act as an oxidizing agent, which converts bromide to bromine. An observation will be red-brown gas is given off. Okay, and which is going to be of 2 marks. So we have to first specify what kind of reagents we are going to use in what condition. If they are asking a single reagent, you will write concentrated H2SO4. If they are asking you a reagent which you are going to use, then we can use silver nitrate. Separate 1 gram samples of 3 different magnesium salts are tested in order to identify the anion present in each sample. So over here, explain how the action of heat is used to identify which sample is magnesium carbonate. So basically, when magnesium carbonate is heated, over here they're asking you action of heat, a thermal decomposition they're asking. So if magnesium carbonate is going under thermal decomposition, so we're going to have magnesium oxide, and along with that carbonates are present. So obviously carbon dioxide gas will release, and we can check this based on lime water turns milky. In that sense also you can write. When we have magnesium nitrate, we will get magnesium oxide, along with that nitrogen dioxide, which will form a brown gas fumes. Okay, and with MgO, which is magnesium oxide, is actually a stable, so nothing happens even though you heat it up. Okay, so these are the observation you may write over here. Next, complete the electronic configuration of magnesium cation present in this salt. Now, obviously, we know that magnesium is Mg, which will be having electronic configuration as 2, 8, 2, right? But now they are asking you magnesium cation. Cation over here, if you would see, all are in 2 plus. So over here, we will gonna write as 2, 8, because there is a loss of 2 electrons. Okay, so how the electronic configuration will be, 1s2 has already been done for the inner shell. Outer shell will be having 8 electrons, so it's going to be 2s2 and 2p6, in total 8 electrons. G, a sample of magnesium carbonate is distinguished from a sample of magnesium hydroxide by adding a small amount of each solid to HCl aqueous. State one similarity and one difference in these two reactions. So first similarity is what that both are in a solid state. That is a similarity, okay, which will get disappear. So both solid will disappear, okay. Then differences that for effervescence is given off when magnesium carbonate reacts with HCl. Okay, there will be a bubbling, there will be a bubble formation, there will be a effervescence when we add magnesium carbonate with HCl. But while talking about the magnesium hydroxide with HCl, there will be no effervescence observed. Okay, so this is a difference between these two. So total of 2 marks. Next question. Second, the strength of interaction between particles determines whether the substance is solid, liquid, or gas at room temperature. So lithium sulfide is given to us is crystalline solid with a melting point of 938 degrees Celsius. It conducts electricity when it is in molten state. So over here they're asking, give the formulae of the particles present. So when I talk about particles, particles can be ions. Okay, so for the ions, I have to write lithium, which is in +1 in group 1, and sulfur, which is 2 minus. Okay, we need to mention the ions as well, the charge as well. Explain in terms of structure of crystalline solid why lithium sulfide has large or high melting point. So first of all, it's obviously a giant structure. Okay, lithium has strong ionic bond, which actually due to the strong electrostatic force of attraction between the charged ions. Okay, writing the interaction, electrostatic interaction is must. Talking about they have a strong ionic bond is also must, and about the giant structure. First will be 1 mark for giant structure and another one for the explanation why it is having a high melting point. Carbon monoxide is a gas at room temperature and pressure. It contains a coordinate bond. Explain what is meant by coordinate bond. So we have done this before as well. Shared pair of electrons provided from the same element, species or atom. So shared pair of electrons from the same element, if that is been coordinate to some other atom, that pairing will be called as coordinate bond. Draw a dot and cross diagram to show the arrangement of outer electrons in CO. So we need to only focus on outermost shell of electrons. So I have done for you. C we are going to represent as X and O we are going to represent as dot. So carbon, you already know that carbon will be having as 2, 4. Okay, so 4 electrons. So I'm going to show 1, 2, 3, and 4. And for oxygen, we're going to have 2, 6. Okay, so over here is going to be 1, 2, 3, 4, 5, and 6. So once we combine this, we will get this diagram. So total of 2 marks. So you have to show the lone pair as well. Okay. C. Nitrogen is also a gas at room temperature and pressure. CO or not N2 is an ideal gas. So over here they are talking about state the assumptions that are made about behavior of particles in an ideal gas. So first thing, whenever we have an ideal gas, no forces or no intermolecular attraction between these particles. Okay, that you can write. There will be no collisions. There will be collision, but there's going to be collisions are elastic. Okay, so these two you can write it down for ideal gas. Explain why N2 does not have or does not behave as an ideal gas at very high pressure. So at very high pressure, gaseous molecules are compressed, as you all know. Okay, because of this, the intermolecular forces will be more. Okay, volume of molecules or particles will no longer be negligible, and also intermolecular force becomes larger. So these are the pointers you must write to get total 2 marks. Complete the table by naming all the types of intermolecular forces, van der Waals, in the separate samples of N2 and CO. So N2 we know that's going to be non-polar, and we're going to have ID forces. Okay, and for the polar, which is carbon monoxide, is going to be permanent dipole forces, PD forces. Okay. Next, suggest why the bond in a molecule of CO contains a dipole moment. Why? Because oxygen is more electronegative than carbon, like this. Next question. A large excess of 2-bromo-2-methylpropane is added to 0.001 mole of NOH, which is an aqueous state, which contains a few drops of naphthalene indicator. A stopwatch is started as soon as the substance are mixed. The time taken for the pink color to disappear is recorded. Okay, so over here we can see the temperature has been increasing while time taken for pink color to disappear is decreasing. Okay, so we can see from here explain what is meant by the term rate of reaction. So change in amount of substance with respect to time is must. Then only you will get total 1 mark. Okay. Question B. The graph shows the energy distribution of molecules in a sample of 2-bromo-2-methylpropane at 25 degrees Celsius. A represents the activation energy for the reaction. So we have molecular energy and proportion of molecules with the given energy. Label the graph to show the proportion of 2-bromo-2-methylpropane molecules with sufficient energy to react. So as you can see this part, the colored one, over here we can see that there will be having a molecules which will have a sufficient energy to react. Which molecules? 2-bromo-2-methylpropane molecules. Okay, the shaded part. Now the next question is been asked. Use the same axis to sketch the distribution of energies of molecules in a sample of 2-bromo-2-methylpropane at 50 degrees Celsius. See, before it was 25 degrees Celsius, now it is 50 degrees Celsius. That means the temperature has increased. So basically what will happen? The curve. If you want to start the curve, you have to start from the origin. So curve will increase and curve will shift towards the right. That means there will be more proportion of molecules and more molecules will be having sufficient energy to react as compared to the previous one. Okay, so as soon as the temperature increases, proportion of molecules will increase. State the effect of an increase in the temperature of EA, which is activation energy for this reaction. There will be no change. Okay, so when we talk about the activation while increasing the temperature, there will be no change. It only changes when there is a catalyst has been added. Okay, and this will give you 1, 3, 4 marks in total. Next question. Draw the mechanism to show the reaction of 2-bromo-2-methylpropane with OH minus. OH minus will act as a nucleophilic show the intermediate formed in this reaction. So over here, we already know that 2-bromo is given. That means halide is present, right? Whenever there is a halide molecule in the halide molecule, and if there is a nucleophilic attack, we always say that it's going to be nucleophilic substitution. Okay, so Br will get removed out. In place of Br, OH will get attached. Okay, that is called as nucleophilic substitution. Nucleophile is OH, right? But before the nucleophile gets attached, we need to create a carbocation. Okay, so for creating a carbocation, we know that bromide, which is Br, is more electronegative, so it will have a partial negative charge. Okay, it will take the electron, and this carbon will have partial positive charge. So we get an intermediate of carbocation. Okay, so we get a carbocation, and over here there will be attack of nucleophile. Make sure that the arrow sign, they are showing you the curly arrows. Curly arrows you should not do from positive to negative, but rather you do it from negative to positive. Okay, so then this OH, which is a nucleophile, will get attached to C plus, which is a carbocation, which is actually behaving like a intermediate. Now once it get attached, so you can see that we have got a new product, which has been an alcohol group, and Br is liberated out. For this reason, you will get 3 marks. Curly arrow, include all the charges. That means this charges also you have to add. Partial charges also we have to add. Lone pairs of nucleophile, curly arrows as appropriate. Okay. Name the mechanism. As I told you, it's going to be a nucleophilic substitution. Okay, quite easy. And we can also say that it's going to be SN1 reaction, because you can add, so OH can come from this side or maybe from this side. Okay, any side it can come and attack, and it is a tertiary alkyl halide. The original experiment is repeated at 25 degrees Celsius with 2-chloro 2-methylpropane instead of 2-bromo 2-methylpropane. So now, before it was bromo, now it is chloro. All other variables remain constant. Predict the effect of using 2-chloro 2-methylpropane compared to 2-bromo. So we have to predict if carbon and chloro along with carbon and bromo. So this one we have to eradicate. We have to predict the bonds. On time taken for the pink color to disappear. So explain your answer. So we can say that chlorine is more stronger than the bromide bonds. Okay, and because it's having a more stronger bond, it will take more time to break the bond. So what will happen? The rate of reaction will decrease because it's taking more time to break the bond, right? So these 2 pointers are essential. Okay, this CCl chloro is coming from 2-chloro 2-methylpropane, and this CBr is coming from 2-bromo 2-methylpropane. Total 2 marks. Next question. Fourth, the table shows a structural formulae of 4 compounds A, B, C, D with a molecular formula C4H8. Okay, so complete the table by giving systematic name. So we need to mention systematic name. As per this, we already know that it's going to be a alkene group. As we can see, it's a double bond. So let's count the number of carbon atoms: 1, 2, 3, and 4. Okay, 1, 2, 3, 4. 4 means bute, and on the first carbon only we're going to have your double bond, so we can write bute 1-ene, or we can also write 1-butene. Okay, now next one over here again, a double bond, which is already given to us, is going to be C4H8. So now over here, as you can see, the bonding. Okay, if you would see, the substituent are attached in the same form. Okay, so it's going to have cis or Z, butene, because butane is the correct answer, 1 and 2. Okay, so we can see 1, 2, 3, and 4. So bute is there, and 1, 2. On second carbon, we're going to have double bond. So we write 2 in. We have to show the isomers as well, because over here cis will take place. Both the atoms are in the same place. Okay, above, and other substituent, which is methyl group, is attached at the bottom. So it's going to be cis or Z, butene. Third one, we can see that it's going to be a trans. Okay, alternatively it has been arranged. So trans, you can also write E, and again 1, 2, 3, 4, which is butene. D. So over here, we can get as 2-methyl prop 1N. How? So if you expand this, you will get as this CH2. You can show the bond. I am not showing. Double bond. And with this carbon atom, we have 2-methyl group attached. We will see if all the carbon valences are satisfied. 1, 2, 3, 4, 1. Okay. Now over here, they're asking us to name the synthetic name for this molecule or structure. So if you would see, it's a alkene over here, right? So we'll start numbering from here. 1, 2, 3. So it's going to have 3 carbon, which is going to be prop. Why 1 in? Because at carbon number 1, we're going to have double bond. So prop 1 in. And on the second carbon, we're going to have a methyl group attached. So 2-methyl prop 1 in. Explain what is meant by stereoisomerism. So over here, we already know that same structural formula, molecular formula, but a different arrangement of atoms group in the space. That is called as stereoisomerism. W is an alkene with a formula of C4H8. It reacts with HBr to form 2 possible carbocations. So over here, they have given 2 possible carbocations. Now from here, we need to specify, from here itself, we have to specify which one will be forming these 2 carbocation. Okay. So basically from the first only we can get an idea. How? Because if you would see, if I add HBr, this bond will break. Okay. And H and Br will get attached. So it can be attached, and also we need to form the carbocation. Okay. We don't need to see for the product, but rather we need to see the carbocation intermediate product. So over here, if you would see CH3, CH2, CH I can get, okay. Carbocation can be from this carbon atom, or it can shift to this carbon atom, okay. So if I compare these two, I will get the same result. Talking about the B1 I'm not going to get, because if I want to break this, I'm going to get over here as a carbocation, okay. Now same is going to be for the C1. For D1, I'll get 2, 1 exactly with this. So I can get over here, or I can get it over here as a carbocation. So the final answer is A. Second one, draw a skeletal formula of the major organic product formed when HBr reacts with W. Now W, you already know that it's going to be ethene, right? And this is nothing but a alkene group. Now alkene group, whenever it breaks, it forms a alkane group. Now we need to form this skeletal formula. I have written over here the same formula, okay, of W. So over here, what will happen? The bond will break because we are adding what? HBr. HBr will come and get attached to, you can attach anywhere. So I'm attaching here carbon Br and H over here, which you can see. And if I want to represent as a skeletal diagram, we can show now how many carbon atoms are there. 4 carbon atoms. So if 4 carbon atoms are there, that means we need to make 3 bond line. 1, 2, 3. And with the second carbon, we gonna have our Br. Okay, so this is your final answer, and which we are going to get as 2-bromobutane as the answer. And as you all know that why only on this carbon? Because secondary carbocation is more stable than the primary carbocation. Okay, so this is the answer, and explain, we have to explain why. So you can also write due to inductive effect. Okay, inductive effect of positive inductive effect, that means there will be 2 alkyl groups attached. Okay, they don't the electrons actually. A sample of propane 1-ol, which is alcohol. Okay, this is an alcohol with a concentrated sulfuric acid to form propene. Identify the role of concentrated sulfuric acid. Sulfuric acid is actually a dehydrating agent. We are actually preparing alkene from the alcohol, and we are using as a catalyst as H2SO4, which act as a dehydrating agent. Alcohol Y reacts with, when warmed with acidified with chromate ions, which is to form Z. Z is distilled from the reaction mixture as soon as it made. Tollens reagent is added of sample Z and warm as silver mirror forms. The silver mirror forms, that means Tollens reagent is actually for identifying the test for aldehyde group. Okay, so here is the positive test. Name the type of reaction that occurs when Y reacts to form Z. So over here we have a dichromate. Okay, and we're gonna have this type of one is oxidation. versus the potassium dichromate is actually act as a oxidizing agent, so it's going to be oxidation. Identify, or actually act as a reducing agent, and is going to be oxidation. Identify with the tick the functional group represent. It's a aldehyde group, which is coming as a positive test for tolerance reagent. Question 5. S is a secondary alcohol with a molecular formula of C4H10O. Draw the display formula of S. So we have 4 carbon atoms, 1, 2, 3, 4. Okay, 1, 2, 3, 4. Okay, and we can add secondary alcohol. That means on the second carbon, we're going to have alcohol group. It's quite easy. S is converted to V in 3-step reaction sequence. Okay, 1, 2, 3. In step 1, the secondary alcohol S reacts with PBr3 to produce T, which has molecular formula C4H9Br. Give the systematic name of T. So as we have seen that it's coming from secondary alcohol. If it's coming from secondary alcohol, it will obviously from a secondary alkyl halide. So it's going to be 2-bromobutane. Why bromo? Because we are reacting with PBr. Okay. Next, name the type of reaction that occurs in step 1. So we know that it's coming from alcohol to alkyl halide. Alcohol to alkyl halide, so obviously there will be OH chance, and that is nothing but the nucleophilic substitution. State the reagent and condition for step 2. Now, as you can see over here, bromide is also present, CN is also present. That means over here they might have taken cyanide group. Okay, so we can use potassium cyanide or you can use sodium cyanide. Okay, in ethanol, so ethanoic you will take with cyanide group. And what will be the condition? Condition will be you're going to heat under flux. So you can write sodium cyanide, potassium cyanide in ethanol, and this will work as a solvent. And you can, the conditions will be, you can write heat under flux. Step 3 involves heating C4H9 cyanide, which is CN, with dilute acid to form V. Complete the equation for this reaction. So we know that it is C4H9 cyanide. Whenever there is a nitrile group which is reacting with hydrolysis, there is a hydrolysis of nitrile group, we are going to get acid. Okay, that too in presence of acid. Again, I'm repeating, whenever we have a nitrile group and we are doing the hydrolysis of nitrile in presence of acid, we're gonna get COOH. Okay, and of course over here N is present. That means there will be ammonia gas which has been releasing out, NH3. But over here we're gonna have H plus, so this will turn to NH4, which is ammonium ions. Okay, and then you can balance it out. So this will be 1, 1, 2. Total 2 marks. 1 mark for this and another mark for balancing. Next question, 5. An unlabeled sample contains either S, T or U. The sample produces the infrared spectrum shown. Explain how this spectrum confirms that unknown sample contains U. In your answer, identify one relevant absorption in infrared spectrum and the bond that corresponds to this absorption in the region of about 1500 centimeter inverse. So over here, if you can see here in our sample contains U. So sample contain U, that means it's going to be a nitrile or cyanide group. Okay, a triple bond. So as you all know that cyanide group will obviously lie in between with this region. Okay, and actually CN shows the peak between 220 to 2250 centimeter inverse. So this region will say is nothing but sample U. So you can mark this as U to get 1 mark.